Mastering API Gateways in Microservices Architecture. In this video, you'll learn how to configure, optimize, and secure API gateways in a microservices environment, enhancing your skills in managing requests between clients and services. Welcome to our deep dive into mastering API gateways within microservices architecture. Have you ever wondered how modern applications manage thousands of requests seamlessly? It's all thanks to API gateways. These powerful tools act as the single entry point for client requests, routing them efficiently to various microservices. In today's session, we'll explore how these gateways improve performance, enhance security, and enable monitoring and scaling in a microservices environment. By the end, you'll be well equipped to implement and optimize API gateways in your own projects.
Why are API gateways so crucial in microservices architecture? Imagine a bustling city where every road leads to a central hub that manages traffic efficiently. That's what an API gateway does for your microservices. By centralizing client requests, it offers enhanced load balancing, traffic control, and security. This centralization is key for scalable and highly available systems. Moreover, API gateways provide built-in logging and monitoring, allowing you to track usage patterns and diagnose issues swiftly. With these capabilities, you can maintain robust and efficient communication between clients and services.
Let's delve into the world of popular API gateway solutions. Whether you prefer open-source tools like Kong and Ginx or managed services like AWS API Gateway, each has its unique strengths. Open-source solutions often offer flexibility and community support, while managed services provide ease of integration and scalability features. Consider your project needs, existing infrastructure, and team expertise when choosing the right tool. Also, evaluate the documentation and community support available, as these factors can significantly impact your implementation and troubleshooting experience. Configuring routing and request handling is a fundamental aspect of API gateways. Start by setting up routing rules that define how requests are directed to specific microservices. Implement request transformation and validation to ensure data integrity and compatibility. Optimize configurations for minimal latency and fast response times, possibly using caching strategies to improve performance. Thorough testing of these configurations is crucial before deployment, as it helps prevent potential bottlenecks and ensures smooth operation in production environments.
Security is paramount when implementing API gateways. Start by enforcing strong authentication and authorization mechanisms to ensure only legitimate clients can access your services. Rate limiting and throttling are essential to protect against abuse and maintain service quality. Encryption should be used for data in transit to safeguard against interception. Keep your gateway software up to date with the latest patches to defend against vulnerabilities. Continuous monitoring for suspicious activities and potential attacks helps maintain a secure environment, protecting both your clients and services. Effective monitoring and logging are vital for managing API gateways. Implement comprehensive logging mechanisms to capture detailed information on request handling, errors, and system performance. Utilize monitoring tools to gain real-time insights into traffic patterns and performance metrics. Analyzing these logs enables you to identify and troubleshoot issues quickly, ensuring smooth operation. Additionally, maintaining logs can aid in compliance and auditing, providing a clear record of activities and changes within your system. Scaling API gateways for high availability is crucial for handling fluctuating traffic demands. Implement load balancing to distribute traffic evenly across your services, preventing any single point of failure. Auto-scaling allows your system to adapt to varying loads, scaling resources up or down as needed. Ensure redundancy and failover capabilities to maintain service continuity in case of failures. Optimize resource allocation and usage to avoid unnecessary costs. Regularly test your high availability configurations to confirm they function as expected under different conditions.
Integrating API gateways with a service mesh can significantly enhance your microservices architecture. Service mesh acts as a dedicated infrastructure layer for handling service-to-service communication, offering advanced traffic control and security features. By integrating your API gateway with a service mesh, you can achieve seamless routing, improved observability, and heightened security. This integration allows for efficient communication between microservices, leveraging the strengths of both technologies to optimize your system's performance and resilience.
Thank you for joining us in this exploration of mastering API gateways in microservices architecture. We've covered the essential roles of API gateways, how to configure and secure them, and strategies for scaling and integrating with service mesh. Now, it's your turn to put these insights into practice. Share your thoughts in the comments, let us know your experiences, and suggest topics you'd like us to explore next. Don't forget to like, share, and subscribe for more deep dives into the world of microservices and API management.